AP Computer Science, here's your project. This is Find Waldo Square. When you run it, the arrow keys will switch between the images. Space bar switches between a before image and an after image. Where do those images get generated, you might ask? The answer is it's the result of the process image method. I wrote my own simple filter, but you can drop your own filter in there later on when you want to. All you need to know is source image is the pre-filtered image and result image is the post-filtered image. Alright, let's write a really... Oh, sorry, one more thing. So, notice this little green dot up here? That's where the default predictor is predicting that Waldo Square exists. Why is that? Well, let's look under Waldo Localizer. This is what you're going to be writing. Here in Waldo Localizer, yours doesn't have that part. Here in Waldo Localizer, find Waldo is the key method. It takes an image as an input and it returns a location as an output. Right now the location it returns is 0, 0. But if we change it to 100, 100, you'll see when I run Find Waldo Square, now the dot has moved to 100 and 100 because that's where, by default, Find Waldo always predicts that Waldo is. Your job is to write the Find Waldo method so that it does whatever image processing you need to do and says, aha, I think Waldo is probably at row 10, column 560 or something. And as long as you get close to the upper left-hand corner of Waldo, that'll count as passing the test. You can see how many tests get passed by running the grader. Here you see it just runs you through all the images, and I failed all 35 tests, and I had a lot of error. Okay, so let's start out together writing a very simple and not very good localizer, but hopefully it'll be better than nothing. So let's go to Waldo Localizer. To start with, let's do something together. You will need to be able to, well, it'll be helpful to be able to generate colors in the way that processing does using the color command, but in order to use the color command we have to have a p-applet, and right now we don't have one. So let's make one. Let's say static p-applet, and let's make a constructor, because right now Waldo Localizer just has an empty, non-existent constructor. So public Waldo Localizer, and I'll say p-applet equals new p-applet. You got to get all your capitalization correct here. And if you haven't imported it already, you'll have to hover over p-applet and say import p-applet. Alright, so now that we have a p-applet, wherever you want to, if you want to make a color, we could do this. We could say white equals p-applet dot color 255, and you recognize this is the regular color command. You probably know it this way as the amount of red, green, and blue. So I've just generated white. Back in Find Waldo Square, you could just say color, because Find Waldo Square extends p-applet. It is a p-applet. Here, we need a p-applet object in order to run that method for us, which is what we just did. Alright, so far so good. So, let's write our basic Find Waldo idea. So, I think the most basic idea is loop through every pixel on the grid, check if Waldo is there. Alright, so let's start that. So, looping through every pixel on the grid. I'll loop through all the rows and columns. So row will start at 0. Row is going to be less than source image. Let's see, row, that's up and down, so less than source image dot height. And I'll say for int column equals 0, C is less than source image dot width. Alright, so far so good. So I'm looping through every pixel on the grid. Let's check if Waldo is there. I want to do something, I guess I need some kind of measure for Waldo. So let's do something really basic. Let's try to count the number of white pixels that are in a little tiny square there. So I'll say int white equals count white pixels. Oops. And we'll figure out the parameters for that in a second. So I'm counting the white pixels, and if white is bigger than something, then I'll return a new location at row column. because row column is where I've just counted the white pixels, and if I counted a lot of white pixels there, maybe that's where Waldo is, so that's the location where I'm going to predict that Waldo actually is. And then, if I never count a lot of white pixels, then we'll just guess that he's at the upper left, which is probably bad. Alright, let's write count white pixels. What information does this method need in order to work? Well, for sure it's going to need the source image. It's going to need to know the row and column where we want to start looking, and it's going to need to know the width and the height of the box that we want to be looking for. So, for example, here I'm commenting this out so that we can run find Waldo square. So see, whoops, whoa. So see this black square there? That's the kind of thing I want to be testing for. So starting from up here, I want to look inside that square and say how many white pixels, and then I'm going to move over and it's going to say how many white pixels, how many white pixels, how many white pixels. And so I'm going to slowly scan across all the possible starting locations. Alright, well, how big is that? That thing is 50 by 50. So let's go back here. I'm going to uncomment these things. Count white pixels needs the source image. It needs our upper left-hand location for starting. And 50 and 50 is going to be the width and the height of the square that I want it to count in. Alright, creating the method. Here we are creating the method. What do I want to do? So I want to loop through a bunch of rows and columns again. I'm going to rename this to SR and SC for starting row and starting column. So I'm going to have row go from the starting row, and I'm going to keep going as long as it's less than the starting row plus, yuck, IJ. What in the world are those? Let's call this width and height. That's going to make a lot more sense. Okay, so the rows that we're going to loop through are the starting row, and it's going to keep looping as long as it's smaller than the starting row plus the height. And we're going to add 1 every time. And we're going to loop through columns at the starting column, and we're going to keep looping as long as column is less than starting column plus width. We'll add 1 every time. So now row and column are looping through every single pixel in a rectangle with this width and that height, starting with that upper left-hand corner. And this rectangle, remember, is coming from the loop up here, which is looping through all possible upper left-hand corners in the image. Alright, what do we want to do with each pixel? Well, the whole point here is we're counting white pixels, so we'll need a counter, which I'll set to 0. And we want to get the pixel color at the row column we're at right now, and then test if it's white, and if it is, we want to increment the counter. Okay, so this involves the one-dimensional pixel array that we have worked with before. I've actually provided you with this method here, getColor, where you give it the p image and the x and the y coordinate. So you can go ahead and use that if you want. I'm going to call my integer pixel color, and I'll use the getColor method, and I'm going to give it the... so let's think about this. So image x, y. So my source image here is called source image. X coordinate is sort of like the column, so I'll give it the c value. The y coordinate is sort of like the row. Indeed, is the row. So I'll give it the row variable there. So now comes the time when I need to test if it's white. We can do this. If pixel color equals... Well, how are we going to get the color white? This is why we made the p-applet up here. We actually can't access the white that we created inside this method because that's a completely separate scope from this method. If we wanted to, we could move this and make this field of Waldo localizer. Yeah, let's do that, I guess. So white is a field of Waldo localizer now. Except let's declare it down in here. Okay, so now that I've got white, I can compare it to white. If you wanted to, of course, you could have said papplet.color and created whatever color you wanted here. Alright, so if it's white, what do I want to do? I want to increment the counter. So let's just double check that what we've done makes sense. I started out with a counter of 0. I loop through all of the pixels I want to loop through. I am now successfully, hopefully, getting the pixel value, and now I test to see if that color is equal to the white color, and if it is, I increment the counter, and at the end, I return counter. Alright, let's uncomment this, and let's see how it performs by running it. I'm not going to run the grader first, I'm going to run find Waldo square, and when I run it, it crashes immediately. Array index out of bounds. Okay, so we should be thinking, where could we possibly have gone out of bounds? Aha. So, the upper left-hand, in find Waldo, I'm looping through all rows and columns all the way to the very right-hand side and bottom of my image. But then I'm using those coordinates as the upper left-hand corner of my search square here, whose size is 50 by 50. So actually what I need to do is I want to say row plus 50 has to be smaller than the bottom of the image, and column plus 50 has to be smaller than the right-hand side of the image, so that way, even after I've added my 50 pixels, which I'll do inside the count white pixels method, I'll still be within the bounds of the image. Okay, so that should have fixed the out of bounds problem. And where's the green dot? So it looks like in this case my localizer predicted right here. I don't see anything particularly white about this area, and now I'm remembering this is actually where it was going to predict if it never found more than 2,000 white pixels. Okay, so I did this on purpose, because this is the kind of thing, this is the kind of reasoning you'll have to reason through. So why did my predictor fail? Maybe counting white pixels is the wrong thing to do. Maybe it's the right thing to do. Let's look. Remember in the introduction when I said you can click and it will run the score region method inside this black square? The score region method is counting white pixels. So I'm counting 0 white pixels, 0 white pixels. Over Waldo I'm getting, as you can see, a lot more pixels, but actually it's only 54, 52. It's not anywhere close to 2,000. So that's the problem. I had a reasonable idea for how to test, I just set my threshold wrong. So that's something that you're going to have to be sensitive to. Maybe if your test isn't working, you need a completely different approach, but maybe your approach would work if you just adjusted some of the values. So let's go back to Waldo Localizer, and instead of 2,000, let's say bigger than 50. And now let's run it again. So now it's a lot closer. It's predicted here, which is not too far off of the actual Waldo square. Let's try it on another image. Pretty close. Pretty close. Not so close. So it's working for some images and not for other images. Let's run the grader. You might notice that this is running fairly slowly, which is to be expected because we're looping through every single pixel, and for each one of those pixels we're looping through a 50 by 50 region. We talked in class about a couple of ways you might want to think about speeding this up. It looks like I'm passing a couple of the tests, but failing a lot more of them. I've set my threshold for passing here to be 30 pixels, so you see 21 pixel error distance passed, but 38 failed. But I'm not failing by very much in that case. In these cases, I'm failing by a lot more. So I can actually go back and check which are the ones that I'm failing, a lot by. Image 4 is the first one, and as I recall, I think it was that one with the skyscrapers. So if we run it, that's image 1, 2, 3, 4, right, the skyscrapers. So, yeah, I was pretty far off here. In the skyscrapers, I'm thinking maybe I don't want to just see if it's got more than 50. Maybe I want to see if it's got more than 50 white pixels, but less than 60 white pixels. Because that might get me right in a tight range around Waldo Square. What are some other things we could try? Maybe instead of counting white pixels, I should count red pixels. Maybe instead of just counting how many white and red pixels there are, I could look for special features. I could try and identify a bunch of red pixels in a band and wherever I see a red band, I know that if I test to see if there are white bands, now I've found Waldo Square. Another idea is you could do a really fast search to get you close to the possible region, and then do a really exhaustive pixel by pixel search right around the region where you think it's likely to be. I'll have a handout that guides you through a couple of these ideas that, again, we talked about in class, but hopefully now this has given you some context for how you're going to put those ideas to work in a program.